Welcome to my channel Crazy to Learn. Today we will discuss the remaining questions, physics questions from previous high school teacher recruitment exam. This is the third part of this series. If you till now did not watch first and second part, link given in my description, you can watch there. Okay, let's start its third part. Our first question is, if a soap bubble is given a negative charge, then its radius increases or nothing can be predicted as information is insufficient, or decreases or remains unchanged. This is the question related to the concept of surface tension. Okay, you should have to know how the question is related to which factor. So this question is related to the concept of surface tension. Okay, and it is given to you, a negative charge is given to a soap bubble. So when a negative charge is given to a soap bubble, due to the electrification, the surface tension decreases. So when surface tension decreases, the size will be increase. Okay, when the surface tension decreases, surface tension is the property by virtue of which the surface area will be decreased. So as the surface tension decreases here, so the size of the soap bubble will increase. Okay, clear? Due to the electrification, what happened? Surface tension decreases. Surface tension decreases means size. When surface tension will be decreased, the size increases. So what will be your answer? The answer is increases. Clear? Question is, the linear momentum P possessed by a body of mass m and moving with velocity v is expressed as. So from the Newton's second law of motion, we know that the rate of change of momentum is directly proportional to applied external force, and from the Newton's second law we derived that the F is equal to ma. Okay, so in that way we can express here the linear momentum possessed by a body of mass m moving with velocity v is expressed as P is equal to mv. It is the direct formula. I think you all know it. So we know the momentum, linear momentum P is the product of the mass and velocity. Okay, P is equal to mv. Our next question is, a person who has short-sightedness is advised to wear spectacles including a concave lens or plane lens, convex lens or concavo-convex lens. The short-sighted defect is also known as myopia. Remember the word myopia. Okay, and another defect is long-sightedness, which is called hypometropia. Okay, myopia or short-sightedness is a defect of eye in which the defected person can see the near object but cannot see the far objects. Okay, this type of defect generally found in our student life. When we are in our schooling time, our friends generally they can read the books easily, but they cannot able to see what is written in the blackboard. That means they can able to read, they can able to see what is written in book. That means they can detect the near object, but they are not able to see what is written in the blackboard. But that means they are not able to watch what is written at a far distance. That means they has the defect of short-sightedness. The eye defect are found in that case. In the student life, generally we are found, when in our student life, our friends they are used to wear spectacles. Okay, their defect, what type of defect they have? They have the defect of eye, which is called short-sightedness or myopia. And when we will ask them what is power of your lens, maximum time we will get that they will say -1.5, -1.75, 0.5. The number what it may be, they will say minus. So minus means the power of the lens is minus. Okay, so which type of lens has a power negative? Which type of lens has a power negative? The negative power lens is your concave lens. So what you get? The person who has short-sightedness or myopia is advised to wear spectacles including a concave lens. Okay, you got the answer. When we are in student life, our friends generally used to wear spectacles which is a concave lens, and they are affected with the short-sightedness eye problem. They are able to see the near object, but they are not able to watch what is written in the blackboard. That means the object which is at a far distance. Okay, and the power of the concave lens, we know it is negative. Okay, and the power of the convex lens is positive. Okay, all are clear? The answer is concave lens. Our next question is, the magnetic flux phi in Weber linked with a coil is given by an equation phi is equal to 8t square plus 3t plus 5. The induced EMF in the coil at t is equal to 4 seconds will be. So we know that the induced EMF small e is equal to minus d phi by dt. It is the formula we know. The induced EMF E is equal to the rate of change of magnetic flux linked with the coil. The induced EMF is equal to the rate of change of magnetic flux linked with the coil. And why it is a negative sign is given here? The negative sign indicates that the induced EMF which is produced due to the change in magnetic flux in the coil is always opposes the change of magnetic flux. It opposes, it does not supports, it opposes. So we are adding a negative sign here. All you are clear? And we know the formula induced EMF is equal to the rate of change of magnetic flux linked with the coil. As here, here it is given to you phi is equal to 8t square plus 3t plus 5. So E is equal to d by dt, derivative of 8t square plus 3t plus 5. So what will be the answer? What is the derivative of 8t square? 8t square with respect to t is what is the formula? The derivative of xn, the derivative dy dx of xn. What is the formula? Nx power n minus 1. Using this formula, when you go, what will be the answer? 2 will come to the coefficient, 2 into 8 into 2, 16, and 2 minus 1 is equal to power 1. So 16t plus 3t, derivative of 3t is equal to 3, and 5 is constant, so derivative is 0. Derivative is 0, plus 0. If you write it, okay. Okay, so the final answer we are getting here 16t plus 3. Okay, this is we got the induced EMF, but it is asked to you the induced EMF at t is equal to 4 seconds. T is equal to 4 seconds, so induced EMF E is equal to, in the place of t just put 4. What will you get? 16 into 4 plus 3. 16 into 4 is equal to 64 plus 3 is equal to 67. And I, from the very beginning, I mentioned you E is equal to minus d phi by dt. The negative sign indicates that the induced EMF, which is produced due to the change in magnetic flux, always opposes the changing of magnetic flux. So we will add a negative sign here. So E is equal to minus 67. And what is the unit of EMF? Induced EMF is volt. Okay, so induced EMF is minus 67 volt. Option C is the correct answer. All are clear? Our next question is, 8 drops of mercury of equal radii possessing equal charges combine to form a big drop. Then the capacitance of the bigger drop compared to each individual small drop is 2 times, 4 times, 32 times or 8 times. So it is based on the one formula. The formula is like when a n number of drops combine to form a big small drop, then the capacitance of the bigger drop as compared to bigger drop compared to E small drop is, the formula is n power 1 by 3 C. Okay, the capacitance of the bigger drop, if we will take C dash, is equal to n power 1 by 3 of C. That means if it is the capacitance of the smaller drop, then the new capacitance is equal to n power 1 by 3 of the C. Okay, so what times it will be, and where n is the number of drops. Okay, so what is the number of drops here? The number of drops is 8 power 1 by 3, that means 2 power 3 into 1 by 3, 3 cancel, the answer is 2 times. Okay, the answer is 2 times. Clear? If the same thing will be asked to you for potential, if it is asked to you for the potential, then potential V dash is equal to n power 2 by 3 V. Okay, so what will be the answer? 8 power 2 by 3, 2 power 3 into 2 by 3, 3 cancel, 2 power 2, then it's 4 times. It's 4 times. Okay, so don't confuse with both the cases. Maximum students, sometimes they will choose 4 times, sometimes they will choose 2 times. So remember, for capacitance it is n power 1 by 3, and for potential it is n power 2 by 3. It is for capacitance, and this is for potential. Okay, don't confuse with both the cases. Okay, so as it is here asked you for the capacitance of the bigger drop compared to the individual smaller drop, it is 2 times. Okay, so answer is option A, which is 2 times. The same problem will be when it is asked to you for the potential, then it is n power 2 by 3. That means the answer will be the 4 times. If it will be asked for the potential energy, it also n power 2 by 3. N power 2 by 3 of the individual potential energy. So at that case it will be 4 times. For potential it is 4 times, for potential energy it is 4 times. Okay, but for capacitance it is n power 1 by 3. That means it will be 2 times. As here the 8 drops is given to you, so 8 power 1 by 3, that means it is 2 times. Okay, clear? Our next question is, Ohm's law is true for which of the following? Semiconductor or metallic conductor or insulators or diode? We know that Ohm's law is valid for at constant temperature and for metallic conductor. So option B is the correct one. Okay, there is no more explanation. Directly you all know Ohm's law is valid for at constant temperature and metallic conductor. Okay, clear? Our next question is, a wire of length 10 meter and cross sectional area 10 to the power minus 6 meter square is stretched with a force of 20 Newton. If the elongation is 1 millimeter, Young's modulus of the wire is in Newton per meter square. It is asked to you, and we know the Young's modulus. What is Young's modulus? The Young's modulus is normal stress divided by longitudinal strain. So first find the normal stress. So normal stress is equal to normal force by area. So what is force is given to you? The force is given to you 20 Newton. So put here 20 divided by area. What is given to you? Cross sectional area. What is the area is given to you? 10 to the power minus 6. Okay, so it will be 20 into 10 to the power 6, or we can write 2 into 10 to the power 7. Okay, normal stress आगे ये न्यूटन पर मीटर स्क्वायर. Okay, now we'll find the longitudinal strain. The longitudinal strain, what is longitudinal strain? The longitudinal strain is change in length divided by original length. Change in length is del L divided by original length. Longitudinal strain is change in length divided by original length. So del L by L. So what is the change in length? The change in length is given to you 1 millimeter. Okay. So del L is equal to 1 millimeter is given to you. So if you write here, so del L is equal to 1 millimeter, and 1 millimeter is equal to 10 to the power minus 3 meter. Okay, as all the length unit is given to you in meter, 10 meter, the original length is 10 meter, so you have to convert this change in length also to the meter. Okay, so it is given in millimeter, so change it to meter. So the del L is 10 to the power minus 3 divided by the original length is 10. Original length is given to you 10 meter. So 10. So 10 divided by 10 to the power minus 3 divided by 10. So when we will take 10 to the numerator, what we will get? 10 to the power minus 3 minus 1, that means 10 to the power minus 4. So the change in length unit is meter, original length unit is meter. So meter divided by meter. So it has longitudinal strain has no unit. So now come to the our Young's modulus. The Young's modulus, what is the value of the Young's modulus? Normal stress by longitudinal stress. What is the normal stress we are getting here? 2 into 10 to the power minus 2 into 10 to the power 7 divided by 10 to the power minus 4. Okay. So if you calculate here, as we have no space above, so I am solving here. Okay. So Young's modulus y is equal to normal stress divided by longitudinal stress. So 2 into 10 to the power 7 divided by 10 to the power minus 4. So when we will take 10 to the minus 4 to the above, what will you get? Plus, it will be converted to the plus 2 into 10 to the power 7 into 10 to the power 4. So answer is 2 into 10 to the power 11, and the normal stress unit is Newton per meter square, and it has no unit. So the final unit is Newton per meter square. The answer is 2 into 10 to the power 11 Newton per meter square. Option B is the correct one. Clear? Our next question: a metallic ring is attached with the wall of a room. When the north pole of a magnet is brought near to it, the induced current in the ring will be first clockwise, then in anti-clockwise direction, or in clockwise direction, or first anti-clockwise, then in clockwise direction. So I already asked to you, the induced EMF is directly proportional to the rate of change of magnetic flux. In the previous question I already discussed with you, induced EMF E is equal to minus d phi by dt. And why a negative sign is given to you here? The negative sign indicates that the induced current, okay, always opposes the change in magnetic flux. The change is magnetic flux. Okay. So similar way, as it is asked to you, a metallic ring is attached with the wall of the room. Okay, a metallic ring is given to you. When the north pole of the magnet is brought to near it, if you think it is a magnet and it is its north pole, and this is its south pole, and when I will brought the north pole to the metallic ring, the magnetic flux increases. Okay, when I will brought near to the north pole of the magnet is brought near to the metallic ring, okay, so the magnetic flux linked with the ring increases. Okay, so here a north pole is produced. Okay, so and when I will take the bar magnet away from the ring, the south pole is, we will get a south pole. So when a north pole we will get, we will remember like this. If you will take, if you write like this N, and for a south pole you will write like this. In different books you will get the picture like this. And when a north pole is formed, the induced current in the ring will be in, this is the arrow mark indicates that it is in anti-clockwise direction. Anti-clockwise direction. And for south pole it is clockwise direction. Okay, this is the north pole when the north pole is developed, when the south pole is developed. When we will bring north pole, we will bring the north pole towards the metallic ring, the north pole will be formed, the magnetic flux linked with the coil increases, so a north pole is formed, so the induced current in the ring will be in anti-clockwise direction. When the question, if the question will be asked to you and it is changed to you, the question is asked to you like the north pole of the magnet is brought away from the ring, then what will be the direction of the induced current? So when the bar magnet is away from the ring, a south pole is developed here, so the current will move in the metallic ring in clockwise direction. But in this question it is asked to you the north pole of the magnet is brought near to the metallic ring, so a north pole is developed here, so the direction of the current will be anti-clockwise direction. Okay, so option B is your correct answer, in anti-clockwise direction. All you are clear? Transverse nature of light can be explained using the phenomenon of interference or refraction or polarization. The answer is option D, polarization. Okay, why? Because we know what is polarization. Now polarization is the process in which a unpolarized light is converted to polarized light. Okay, what is polarization? The process of polarization is transforming a unpolarized light to polarized light. And what is unpolarized light and what is polarized light? Unpolarized light in which the particles vibrate in many planes, but polarized light means when the particles vibrate in the same plane. Okay, when the particles vibrate in different planes, then it is unpolarized light. When the particles vibrate in same plane, then polarized light. Okay, and the process of transforming unpolarized light to the polarized light is called polarization. So by the phenomenon of polarization we can explain the transverse nature of light. So polarization is the correct. Our next question is the impulse imparted to a ball of mass 0.15 kg when the batsman hits the ball without changing its initial speed of 14 meter per second in the direction of the bowler is. Assume linear motion of the ball, it is given to you. Okay, so we know what is impulse. The impulse is equal to force into time. Otherwise we can write impulse is the change in momentum. Okay, change in momentum. So in this given case we can find out the change in momentum. As we know, the momentum is mass into velocity, and mass is given to you and velocity is given to you. First the bowler throws the ball with velocity 14 meter per second, then the batsman hits the ball without changing the initial speed, it is given to you. That means with the same velocity. So what is the change in momentum? So first the final momentum is mass into velocity. Okay, we know momentum. What is momentum? Momentum P is equal to mass into velocity. So change in momentum is final momentum minus initial momentum. Final momentum is equal to mass is 0.5, sorry, mass 0.15 into velocity is 14 minus initial velocity. So when bowler throws the ball in this direction, if you think bowler is here and batsman is here, okay, when bowler throws the ball in this direction, then batsman hits the ball, this is given to you in the direction of bowler, in the direction of the bowler. If you take this velocity is v, this velocity is minus v, because it is in the opposite direction. Yes or no? Batsman hits the ball towards the bowler in the direction of the bowler. If you take this velocity as v, the throwing of ball from bowler to batsman is minus v. So in the initial momentum will be same mass into velocity. As batsman hits with the same velocity, in the initial case the velocity is same, we can take it as a minus 40. Okay, clear? As here we are taking minus b. Okay, now calculate. What will you get? 0.15 into 14 means 15 by 100 into 14. 15 into 14 is equal to 210 divided by 100. 0 cancelled. 21 by 10 is equal to 2.1. Okay, here we will get 2.1 minus 2.1. So which is equal to 2.1 plus 2.1, which is 4.2 Newton second. Okay, so which is the correct answer? Option A is your correct answer. What is the impulse? The impulse is the change in momentum, and the final momentum is 2.1 and the initial momentum is 2.1. But velocity in opposite direction, so we will take it as negative. So minus plus, it will be 4.2 Newton second. Clear? Question is, the velocity of the transverse wave in a stretched string is given by when the capital T is the tension of the string and m is the mass per unit length of the string is given to you. Then the velocity of the transverse wave, it is the direct formula we know. Okay, velocity v is equal to tension of the string divided by mass per unit length square root. Okay, in my previous video I already discussed about this thing, velocity of the transverse wave and velocity of the longitudinal wave. Okay, and velocity of the transverse wave when rigidity modulus eta is given to you and density of the material rho is given to you, then formula is velocity of the transverse wave is equal to eta by rho square root of eta by rho. You can use this formula also. When in case of stretched string, the formula is like this, and normally the formula is like this. Okay, when the transverse velocity of the transverse wave in case of stretched string is asked to you, then we have to know about the tension of the string and mass per unit length. Then velocity is square root of tension of the string divided by mass per unit length. Okay, and when the rigidity modulus is given to you and density of the material is given to you, at that case eta by rho square root. Okay, square root of eta by rho. Clear? Our next question is, the specific resistance of all metals is most affected by temperature, degree of illumination, pressure or applied magnetic field. And it is, we directly know, the specific resistance of a metal depends upon the temperature. Okay, depends upon the temperature. So the answer is option A. Here we will completed all the 30 questions from the physics of 6th March second shift. Okay, next I will come with the physics questions from different shifts. Okay, till that time take care, keep preparation. Bye bye, have a nice day. Bye.